All right, so this one here is going to be our last part 4 of page C here. There were a lot of things here that are very important and some things you might not have gotten a lot of time to learn last year in algebra with the year having been cut short, or, well, whatever you want to call it. So we're going to be solving these quadratics using the quadratic formula, and so that's written right here. X is equal to the opposite of b plus or minus the square root b squared minus 4ac all over 2a. A, b, and c are just numbers. They're numbers that are the coefficients in our quadratic equations here. So let's just go ahead and pick one of these to do, let's say, number 20. So this would be our A. A is 3. This here would be our B, negative 5. It's a negative because there's a minus. And this would be our C, 8. I'm just going to take those 3 numbers and plug them into the quadratic formula, carefully evaluate that, and come up with our 2 solutions. We're going to get 2 solutions because of this plus or minus symbol. One where we add, one where we subtract. But I'm not going to write it out twice. I'm going to simplify as much as I can and then kind of do the plus or minus part at the end. Okay, let's go ahead and write this out. So x is equal to the opposite of b. So the opposite of negative 5 is 5 plus or minus square root of b squared. So negative 5 squared minus 4 times a, which is 3, times c, which is 8. All of that divided by 2 times a, 2 times 3. So once we plug everything in, it just becomes a matter of carefully simplifying this out. I'm going to do a little kind of calculations on the side, so I don't have to rewrite this a bunch, but negative 5 squared is going to be 25. 4 times 3 is 12, times 8 is 96, and 2 times 3 is 6. Okay, 25 minus 96. Negative 71. All of that divided by 6. Okay, so we've simplified quite a lot. Actually, pretty much as far as I'm going to expect us to do in this class. Later on, you'll take this a little bit farther. If you try to evaluate the square root of negative 71, you're going to have a problem. You can't take the square root of a negative number and get a real number. You can get an imaginary number, which do have important applications, but right now, what we're going to say is that this problem here, because of this negative inside of our square root, is going to have no real solutions. No real solutions. So no real number values of x will actually make that equation true. And yeah, let's go ahead and do, oh, I don't know. Let's do number 21. Might as well. I think that one's going to give us a real solution, so let's do that one. So our A is 4, B is negative 9, and our C is 12. Okay. Our X is equal to the opposite of B, positive 9, plus or minus the square root of negative 9 squared minus 4 times A, which is a 4, times C, which is a 12. And there we go. And all of that, 2a, 2 times 4. All right, so again, I'm going to do a little simplifying on the side. And as I look at it, actually, I don't think this is going to be a real answer, but it's okay. And 4 times 4 is 16 times 12, 192. Okay, and 2 times 4 is 8. And I'm just kind of doing this so I don't have to rewrite it a bunch. All right, 81 minus 192 is negative 111. Okay. Well, As I did quite a bit of simplifying here, again, I run into this situation where I have a negative inside my square root. Again, that's going to be an imaginary number, so I can point back to this. Again, this one's going to have no real solutions. Kind of disappointed. I wanted to show one with a real solution. So I guess we'll go back and go ahead and do number 19 in the hopes that we have a real solution here. All right, this one, there's no number there. So remember, there always is a 1. So our A is a 1, B is 12, and C is -9. All right, let's go ahead and plug those numbers into that quadratic formula again. X is equal to the opposite of B, so -12, plus or minus the square root of B squared, 12 squared, minus 4 times A times C. All right, all of that divided by 2 times 1. I'm going to try to do those calculations on the side again. 12 squared is 144. -4, because we have kind of two negatives here, we're really going to end up with plus, so it's going to be plus 36. And I multiply that out, and then 2. All right, 144 plus 36 is 180. -12 plus or minus square root of 180, all that divided by 2. All right, so this time we have a real number in here. We're going to get a real number. We can take the square root of 180. It's not a particularly nice number, right? It's going to be somewhere between 13 and 14. We're getting a decimal, but you can also simplify that as a square root. You can go back and watch the page B videos if you want to know how to simplify this as square root, but it's going to simplify as 6 square root 5 over 2. And then kind of as our final step, we want to check to see if we can kind of either divide this number through, divide everything by 2, which that actually works really well this time, or if there's a common divisor for all of these numbers that maybe isn't this. Say this was like an 8 or something. All of these numbers would be divisible by 2, therefore we could simplify it. Yeah, but in this case, it actually just divides through really nicely. And we can get -12 divided by 2 is going to be -6. 6 divided by 2 is going to be 3. So a lot of times you would see this answer written this way: -6 plus or minus the square root of 5. It's not the most beautiful answer, and you could use a calculator if you wanted to get a decimal approximation of those two solutions. But for us, we're just going to leave it that way. That is an exact answer.